Hello guys, in a new session I will be talking about chapter 5. Chapter 5 includes two sections. The first section will be talking about the reaction mechanism, and the second one about the rate of the reaction. We will be talking about each of them in detail. Let us talk about the reaction mechanism, and then we will be talking about the reaction rate. Guys, for the mechanism of the reactions, usually in chemistry, the reactions, they process with different speeds, A reaction mechanism that is slow mechanism, and another one which is a fast mechanism. Chemists have found that chemical reaction occur with widely different rates. For example, guys, iron here, rusting of iron, was the reaction of the oxygen and iron at the presence of water. This process is slow mechanism. It is a slow mechanism, but methane, combustion of methane, this is a fast mechanism. Fe with O2 to produce Fe2O3, or CH4 with O2 to produce CO2 plus H2O. This here we have the reaction with the oxygen, but iron combusted with oxygen much slower than the methane. That's why these processes, they have different speeds, different speed of the reaction. The speed of a chemical reaction depends on two factors: the energy path that the reaction follows, and the change that takes place on a molecular level when substances interact, guys. Of course, when we have two paths of reactions, reactant to product, let me draw another path of reactant to product. In here we have got two paths. The blue one is longer path, and the red one is a shorter path. So the blue one takes more time to process because it's longer. The red one is shorter, the path is shorter, takes little time. This is the first, a lower time. This is the first factor that influences the speed of the reaction, the path of the reaction. The second, the changes that happen during this path, the changes in the system, the temperature, pressure, volume of the system changes. There will be this factors influence on the speed, the rate of the reaction, changes during the reaction. A reaction mechanism, guys. For mechanism of the reactions, usually the reactions, they process in steps. They do not process through a single reaction which we represent. Those reactions, the overall reactions, process within several steps of reactions. Guys, whenever we mix HCl and NaOH, there will be a neutralization reaction between hydrochloric acid and sodium hydroxide. And the net equation is hydroxide plus hydronium to form H2O, because Na and Cl, they become spectators. The rate is limited by what? By the speed with which the hydronium and hydroxide can diffuse through the water to meet each other. What will determine the rate of the reaction, become a fast mechanism or a slow mechanism? The hydronium and hydroxide reaction, if the existence of hydronium and hydroxide in the reaction in the medium is high and they meet frequently and react to form water, that will be a fast mechanism. If it's not, that will be a slow mechanism. On the other hand, reactions between ions of same charge and between molecular substances are not instantaneous, are not rapid. Guys, whenever we have the same charges, the same charges. The charges, when they approach towards each other, they repel each other. Positive, positive, and negative, negative repel each other. That's why there is repulsion force between those ions. They will not be able to attract with each other and react. Negative ions repel each other, so as do positive ions. The electron clouds of molecules also repel each other strongly at very short distance. Only, guys, only ions or molecules with very high kinetic energy can overcome repulsion force or repulsive forces and get closer to react. What do we mean by the clouds, guys? Suppose we have two atoms of two different elements. Two atoms of two different elements. They have the different when these two clouds they approach toward each other, what the clouds they carry? Electron. The sign of electron is negative, and then when they approach toward each other at a very short distance, the electron clouds they repel each other. They will not be able to react and combine. We have to provide an amount of energy to overcome this repulsion. That amount of energy should be added for any reaction in order to process. And this repulsion force, we have to overcome on the repulsion force in order to let the electron clouds to form bonds, whether it's sharing electrons or transferring permanently the electrons. That's why we said here, the electron clouds of molecules also repel each other because they both carried electrons. But only the molecules they have a very high kinetic energy. The very high kinetic energy overcome on this repulsion force and let the molecules to attract and react together. Here we have the reaction of the HCl and NaOH, which also represents the neutralization between those two chemicals. Guys, the many chemical reactions don't occur in a single step. As I told you that the chemical reactions, they occur within several steps. They will not occur in a single step. For example, step 1 and step 2, when we combine this, we will get the overall or the net equation. We have to know how to add the steps. The steps, we are able to add the steps in a mechanism if the same chemicals in opposite sides of two steps, they should be cancelled with each other. If in the same side, we add them together. For example, here the C cancelled with the C because they are in opposite sides. D cancelled with the D, they are in opposite sides. So the result represents AB goes to form EF. If something, for example, here we may have A, there should be A plus A to A. We add those that they exist in the same side. So what's a reaction mechanism? A reaction mechanism is a step-by-step sequence of reaction by which the overall chemical change occurs. A reaction mechanism or mechanism of a reaction is what represents the individual steps which they process and form an overall reaction. For example, guys, here we have the reaction between H2 and I2 to form 2HI. HI is colorless and I2 is violet. Guys, hydrogen iodide molecule in turn tend to decompose the formation of hydrogen iodine. Here the hydrogen iodide molecule tend to decompose and reform hydrogen and iodine molecules, producing the violet gas. In the above, guys, we have the process of formation of hydrogen iodide and here we have the decomposition of hydrogen iodide. Both processes are occurring, this is a reversible reaction. But guys, the H2 and I2, when we add them into a container, a closed container, they will not react spontaneously with each other. Why? Because as I2 and H2, they come closer, the atoms comes closer to each other, they will, the electron clouds repel each other, and there will not be a spontaneous reaction between those two clouds. Only the net chemical change is directly observable for most chemical reactions. Experiments can be done to suggest the probable sequence of steps in a reaction mechanisms. We will be talking about those experiments. We have two mechanisms. Each reaction step is usually a simple process, and the equation for each step represents the actual atoms, ions, or molecules that participate in that step. For the mechanism of the formation of hydrogen iodide, you have to memorize both mechanisms. The first mechanism occurs in 2 steps, the second mechanism in 3 steps. Let us do the steps, guys. Step 1 and step 2, this is the first mechanism, guys. The first mechanism, mechanism 1. I2 changes to 2I, and then 2I reacts with H2 to form 2HI. Here the 2I with the 2I cancelled out, and any element, any species that appears in one step in a product and reactant of the following step cancel it with each other, we call as the intermediate. We will be defining the intermediate in detail, guys. So the result, we will get H2 plus I2 to form 2HI. The second possible mechanism for the formation of HI follows 3 steps. The first step is the same as the first mechanism, which is I2 forms 2I, but instead of both I's react with H2, one of the I bags to react with H2 to form H2I, and then H2I reacts with one of the remainder of the I remainder to form 2HI. So here the 2I, I plus I, 2I cancelled with those 2I, H2I with the H2I cancelled out, you get the same result of the net equation, which is I2 plus H2 to form 2HI. Guys, you have to memorize these two mechanisms of formation of HI, because there will be questions like that. Which of the steps is the step of the mechanism of formation of HI, or is not a step in the mechanism, or there may be other questions which need us to memorize these two mechanisms, guys. Colorless hydrogen iodide gas, HI, decomposes into colorless hydrogen gas and violet iodine gas. Some of the hydrogen gas and iodine gas will reform HI. So this reaction is a reversible reaction. They can both reform the reactant, the product can back to form the reactants. What's the intermediate, guys? Species that appear in the steps but not in the equation are the intermediates. Example for the intermediate in the above mechanisms, H2I cancelled with H2I, I with the 2I, I with the 2I. So the I and H2I, they are both intermediates. Why? Because they appear in the mechanism but disappear in the main equation. But guys, we have another species which appear in the mechanism but disappear in the equation. We call as the catalyst. There is a difference between catalyst and intermediate. We'll be talking about that in section 2 in detail. But let me tell you the difference simply. The catalyst appear in the reactant of the first step and the product of the final, but intermediate in the product of one step and reactant of the following step. product of one step and reactant of the following step. Or we can say if the reactant has the catalyst and the reactant of the first step and the product of the last is the catalyst, the opposite, which the reactant of the product of the first and the reactant of the last, is the intermediate. So guys, here in this process, the composition of nitrogen dioxide exists in two steps. We will be able to calculate the missing steps. I will show you how to calculate the missing steps when one of the steps and the main equation is given, how to calculate the missing steps. Set it's in two steps. One of the steps is given, how to predict the possible second step. For this, to find the missing steps, always reverse, flip the given step, add with the main, you'll get the missing step. So the main equation rewrite the same. NO2, 2NO2 will produce 2NO plus oxygen, and flip the given step, it will be NO plus O will produce NO2, and then add them together, you'll get the missing step. Guys, NO2 with 2NO2, 1NO2 is the remainder. NO with 2NO, 1NO is a reminder. There is nothing else can be cancelled. Guys, be careful. O and O2 are different. They are not the same. So do not cancel them together. NO2 plus O will produce NO plus O2. This is the missing step, which here we calculated. That's how we can calculate the missing steps. Just flip the given step, add with the main, you'll get the missing step. We solve it, find the first step by using the given reaction. Guys, we have got two types of reactions, a homogeneous reaction and a heterogeneous reaction. A homogeneous reaction, we mean the reaction that the reactants and products exist in the same phase. A reaction whose reactant and product exist in a single phase. Gas, 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 aqueous, aqueous, aqueous. We do not have solid that homogeneous. Aqueous and liquid states are homogeneous, not gases. So guys, have a look. If we take in this mechanism, we have got two steps and the net. Individually, if we take the steps or the main equation, one of the individual reactions, gas, 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 this reaction is a homogeneous reaction. Why? Because the reactant and product are all gases. The steps, gas, gas, gas. So we have what? Homogeneous reaction, individual step. But we have got another term which we call a homogeneous chemical system. What's a homogeneous chemical system? A homogeneous chemical system, all reactants and product in all intermediate steps are in the same phase. The mechanism, all, for example, the first step, gas, 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 second, gas, 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 main, gas, 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 all the mechanism, we have the same phase. That will be a homogeneous chemical system. If intermediate is in the product, that step will be the first step. This will be, we'll talk about this in rate law, finding the rate law. If intermediate is in the reactant, that will be the second step. And the homogeneous will be for the aqueous and liquid, not for solid. And gases as well, we can say. We'll be talking about collision theory and three possibilities. This theory talks about the gases especially, because the gases, they move freely and they collide each other. That's why we'll be talking about the collision theory, the three assumptions. In order for reaction to occur between substances, their particles, molecules, atoms or ions must collide. Furthermore, these collisions must result in the interactions between those particles. The set of assumptions regarding collisions and reaction is known as the collision theory. We have a set of assumptions, 3 assumptions. We'll be talking about them in detail. Those assumptions are all the assumptions of the collision theory. For a reaction to take place, molecules must collide, but to be effective, the molecules must collide with 2 conditions: a favorable orientation and enough energy. Favorable orientation, we mean the angle of collision. The angle of collision. If guys, there will be a key. If this key with the locker, there will be a locker. If the key entered to the locker with the opposite direction, that will be unfavorable orientation. If it is added to the locker with the appropriate direction, that will be the direction that opens the door. Or if it's not appropriate, opposite, it will not open the door. That's we mean the appropriate orientation. And we have to, with the appropriate orientation, the collision must be with enough energy, with high energy, in order to be effective. So the direction of the orientations must be appropriate, and then the enough energy. Let us talk about this reaction, which is AB. AB goes to form A2 and 2B. Here we have got three assumptions, guys. One of the assumption is effective. The 2 others are ineffective. Let us talk about the effective and ineffective. Have a look on the first, the AB molecule. The AB molecule, here they collide each other. The orientation is favorable orientation. Why? Because the molecules, the yellow, they collide each other, and then with the blue at the same angles. So they have a favorable orientation and with enough energy. So they produce the product of A2 plus 2B. A2 plus 2B. And this collision we call as effective collision because it's favorable orientation and energy. So whenever the collision has favorable orientation and enough energy, there will be a formation of product, and the reactant, when they collide, they will form product without rebounding to the reactant. And this collision we call as what? As the effective collision. This is the first. Second assumption. The collision favorable orientation has favorable orientation. They collided with the appropriate orientation, but it's too gentle. Too gentle means what? Means lack of energy. Lack of energy. It has not enough energy. So whenever one of the conditions is missing, the reactant, they collide each other, but they do not form product. They rebound to reactant without forming any products. So AB, they collided to form a rebound to AB and AB without forming new products. This we call as the ineffective collision. So whenever the molecules collisions between the collisions between the molecules is too gentle, means it's low energy, has no appropriate amount of energy, then we call as the ineffective collision. The molecules of reactant, when they collide, they rebound without forming any product. The third assumption, guys, as you can see, the angle of the collision is not appropriate. So here it has no appropriate orientation or poor orientation. So the collision may be with the high enough amount of energy collided, but the orientation of the collision is important also. It is the reactant AB, they rebound to AB and AB without forming new products. So again, this collision is what is ineffective collision. So the collision theory has three assumptions. The first one is effective collision, which the appropriate orientation, the collision has appropriate orientation and enough energy. The second and the third is they are not effective, ineffective collision. The second with not having enough energy. The third with a poor orientation. Both cases are ineffective collision. Effective collision, two conditions are supplied of enough energy and favorable orientation. Here, one or both conditions are not supplied, no energetic enough or not favorable orientation. Here, product will form, here reactant reform to reactants without forming the products. An example which is given in our book for the orientation, guys, said in our book, when the reaction between nitrogen monoxide and chlorine, if the chlorine collides the oxygen and if it collides with the nitrogen, if it collides the nitrogen, there will not be a reaction, no reaction. If it collides with the oxygen, there will be a reaction. Why? Because the appropriate orientation of collision to form product is what is the collision of the chlorine with the oxygen, not with the nitrogen. If it collides with the nitrogen, there will not be a reaction. Decomposition reaction does not need collision theory. Why? Because the collision theory is all about the colliding or the particles, they strike each other. In decomposition, the molecule is not colliding, it's decomposing to form the elements. Collision theory only used for gas phase reaction. Why? Because the gases, they collide more frequently than other states of matter. Here we have got activation energy, guys. In order to understand the activation energy, let us answer the question that said, when we have a reaction of hydrogen and oxygen, why don't oxygen and hydrogen combine spontaneously and immediately to form the H2O when they are mixed at room temperature? The formation of H2O is spontaneous. Spontaneous means the formation is exothermic. According to enthalpy, is spontaneous. So guys, this reaction between H2 and I2, why is not spontaneously processing? The reactions between those two atoms, as we talked about at the beginning of the session, we said as the molecules of these two atoms approach to each other, their electron clouds, they repel each other. So because of having repulsion force of the electron clouds between those two atoms, there will not be a spontaneous reaction between those two atoms. Instead, we have to add an amount of energy to overcome the repulsion force between those two atoms to form the H2O. That amount of energy we call as the activation energy. So when the molecules approach each other, the electron clouds repel each other, so the molecules may not meet each other. For reaction to occur, the colliding molecules must have enough energy, kinetic energy, to intermingle the valence electrons. We have to provide enough energy in order to let the valence electrons to bond, to form bond. The bonds of this molecular species must be broken in order for new bonds to be formed between oxygen and hydrogen atoms, and we have to provide the amount of energy in order to form the bonds between those two atoms. Usually, you know that breaking of bond is endothermic. Why? Because in order to break a bond, we need to provide energy, but forming bond is what is exothermic formation of bond releases amount of energy to the surrounding. Energy from an outside source may start exothermic reactants along the pathway of reaction. We have to provide an energy from the outside source in order to ignite the reaction or to start the reaction. The energy, an initial input of energy is needed to overcome the repulsion force that occur between the molecules when they are brought very close to each other. In order to overcome on the repulsion force, we have to apply or supply an initial amount of energy, and that initial amount of energy input activates the reaction. So the minimum amount of energy required or needed to activate this process, this reaction, is the activation energy represented by EA. So what's the activation energy of EA? Is the minimum amount of energy required to transfer the reactant into activated complex. EA is the amount of energy which transfer the reactant into activated complex, which the peak point of the path of a reaction we will be showing on a graph graphically. You'll understand the activated complex. Activation energy must break existing bond and form new bond in order to let the hydrogen and oxygen to react. So the activation energy must be supplied even for the exothermic reactions in order to start the reaction. What's the activation energy, guys? Here the activation energy is here we have got a reactant and then a product, and then activated complex we call as the IC. We'll be talking about the property of IC in detail in the coming pages. So guys, in order to transfer the reactant into the activated complex, we need an amount of energy, and that energy we call as the EA, or activation energy. So simply, the amount of energy which is required to transfer this reactant into the IC is the EA. With the EA for the forward process, for the reverse, if the product has tendency to back to the reactant, it needs an amount of energy to back to the IC, and that we call as the EA prime. So what's the EA prime? Is the activation energy which required, or is the minimum amount of energy which we require to return back the product into the activated complex. So in between the reactant and IC is EA, in between the product and IC is the EA prime. So EA is equal to what, guys? We have several equations in this section, 6 equations, guys. EA is equal to IC minus E reactant. This is the first equation. Second equation, EA prime is equal to IC minus E product. Why? AC minus E product results this distance. AC minus E reactant results that distance. So EA can be calculated by subtracting the E reactant from AC. EA prime can be calculated by subtracting the E product from the AC. So for the reactions, guys, we have got we talked about 2 equations. We have got more equations. Delta E forward equal to EA minus EA prime. Delta E reverse is equal to EA prime minus EA. Delta E forward equals the negative delta E reverse. We mean delta E forward is equal to the opposite sign of the delta E reverse. These are 2 equations. Suppose it's 1, 2. The other equation, delta E forward, in terms of energy of reactant and product, equal to the energy of product minus energy of reactant. This is the third equation. Delta E reverse equals the dot energy reactant minus energy product. This is the fourth equation, the fourth. And we mentioned the other two equations. EA equals the AC minus EA prime. AC minus E reactant. EA prime is equal to AC minus E product. These are the fifth and the sixth equation. So in this section, to solve EA prime, delta E forward, delta E reverse, we just use these equations in order to process the solutions of the questions. Rate of the reaction, guys, with the EA is inversely proportional. Why? How? Have a look on this graph, guys. Suppose we have got a graph like this. Reactant goes to the product. Let me draw another graph. Reactant goes to the product. The blue one, the EA for the blue one, and the EA for the red one. The EA of the red one is higher than the blue one. So having a higher EA lets the reaction rate to be slower, the reaction mechanism to be slower. So the speed of the reaction with EA is inversely proportional. And another note, EA and EA prime cannot be negative values, guys. You have to know that these two quantities cannot be negatives. Let us talk about the activated complex and the properties of that region. Guys, the activated complex graphically is the crest of the graph, is the top part of the graph, which is in the highest position of energy. A transitional structure that results from an effective collision and that persists while all bonds are breaking and new bonds are forming is what is the activated complex. So what's the activated complex? Is a transitional structure. A transitional structure we mean is a temporary period of time. It stays for a temporary period of time. In this structure, what will happen? The old bond of the reactant are going to break down. This is the IC region. And then the old bonds break down to form new bonds of the product. What are the properties of the A activated complex? What will happen in activated complex, guys? First, activated complex is a transitional state. Transitional state means what? Means the reactants, they have solid bonds, but they pass through a region which is for a short period of time, and they have not a solid bonds. And then they will form product or rebound to reactants. So the activated complex is a transitional state. In terms of energy, guys, they are having the highest position of energy on the path of the reaction. And in terms of stability, they represent the highest instability. Why? Because they are in the top position of energy. So in terms of stability, they are unstable. In terms of lifespan, they have a short-lived structure. They are a short-lived structure. It's just somehow, guys, in this region, it's short, a transitional structure, and is the top, the crest of the graph, highest position of energy, and the highest instability is in, or the least stability of the graph. Guys, in the activate, this was the ministerial exam question, one of the ministerial exam questions. What is the bonds in this region are for what? There is possibility only to form product, or there is possibility to rebound to reactants. The bonds at activated complex are for both reactants and product. So partially for reactant, partial for products. We cannot say that always product format or rebounds to reactant. The activated complex partially for reactant and partially for products. It may then reform to form the original reactant or may break down to form new bonds and new products. What's the temperature relation between temperature and reaction rate? The rate of the reaction, of course, increased by increasing temperature. In terms of that, the intermediate and activated complex, they are both short lived structures. We may confuse them, so let us differentiate between them. Activated complex bond partially broken and partially formed, partially for reactant and partially for product. But here the bonds are formed in one step, reacting in another step. Distinct molecule formed in one step, react to in another step to react and consume in another step. That's the first difference. The second difference in terms of energy level is a high energy state, but the intermediate is in the low energy state. As it is in the higher energy state, it's unstable, and the intermediate is more stable than the activated complex, guys. Here are all the graphs representations for the activated complex, but you have to know that the activated complex bonds in activated complex are for both reactants and products. Here we have got the equations. EA equals to E activated complex minus A reactant, EA prime, the activated complex minus product, delta E forward equal to minus delta E reverse, delta E forward EA minus EA prime minus EA for the reverse. In endothermic process, guys, delta E, you know that higher than 0 and EA higher than EA prime. You have to know this. For exothermic, delta E lower than 0 and EA less than the EA prime. If energy level of the reactant start at 0, so the energy of activated complex EAN is equal to delta E forward and equal to the energy of the product as well. So guys, if we start at 0, suppose 0 reactant and AC is 100, okay, this is suppose is 50, the AC is 100. So the reactant product, if reactant is 0, this difference will be the same as AC. 100 minus 0, you get the same. So EA is equal to the activated complex. Delta E forward equal to the energy of the product. Of course, delta E forward is equal to what? Energy of product minus reactant. 50 minus 0 is equal to 50. So whenever we start at 0, you have to know these two notes. The AC is equal to EA and delta E forward is equal to the energy of product. Let us solve some of the questions. This is a sample problem. The graph is given and requires to find EA prime, delta E forward, delta E reverse. Guys, graphically, this is the AC and energy of the reactant and the position of the product. And this reaction is what? Is the endothermic reaction. Why? Because the reactant is in a lower position of energy than the product. EA is in this region, so the reactant starts at 0, EA is equal to activated complex, so EA is equal to what? 80 kilojoule per mole. This is the first. EA prime, guys, is equal to the difference between AC and E product. So AC is 80, E product is 50, 80 minus 50 results at 30 kilojoule per mole. That's the EA prime. Delta E forward equals the product minus reactant. 50 minus 0 is equal to 50 kilojoule per mole or 50 kilojoules. Delta E reverse just equal to the opposite of the above, which is minus 50 kilojoules. That's how we can solve, if the graph is given, we can solve for the EA prime and delta E forward and delta E reverse. Guys, simply here the 0 is the reactant, so EA is equal to 100 kilojoule per mole. EA prime is equal to, this is exothermic, why? Because the reactant is higher than the product. 100 minus 150 results at 250 kilojoule per mole. This is the EA prime. Delta E forward is equal to product minus 150 minus 0 is minus 150. For the reverse is equal to 150. That's how we can solve all the quantities graphically. Same, guys, same types of questions. Let us solve also this. Set, draw and label an energy diagram similar to one shown in the sample problem for reaction EA 125, EA prime 86. Place the reactant at 0. So placing reactant at 0, here the drawn one, and EA is equal to 125. What will be the position of AC? We said whenever we start at 0, the AC is equal to EA, so you have to reach to 125. Why? Because EA is 125. And then where should be the product position? Guys, the energy of forward is equal to EA minus EA prime. Subtracting these two values results what? The value of, how to determine the position of the product. The position of product delta E forward is equal to EA minus EA prime. Okay, EA is 125 minus 86. Almost will result at 39. I think it's 39. So the position of the product is what should be in the 39. Why? Because delta E forward equals the E of product when the starting of the reactant is at 0. So that's how we can find or draw the graph and show the graphs if the quantities are given. Another questions, guys. So there are several questions. Here we have the test bank. Let us solve some ministerial exam questions in this section, and then we will end up the session. The graph is given, and here the quantities are given as well. So this graph, the EA is equal to AT. EA80, so B and D, C and A cancelled. EA prime is equal to 80 minus 30, 50. So 50, both are 50. So let us delta E forward. Delta E forward is equal to 30 minus 0 is equal to 30. This one is negative 30, this one 30. So D is the correct answer. To be effective, collision requires what? Favorable energy and orientation. This we talked about this in collision theory. Another form of the graph, the EA and delta E forward calculated. EA is equal to 70, so 70. A and C, B and D cancelled. Delta E forward is equal to 30 minus 0 equal 30. This A is negative 30 and C is the 30, so C is the correct answer. The bond is inactivated complex. Both reactants and product is partially for reactant and for product. These are the ministerial exam question, guys. Which of them wrong? Guys, EA is 20 kilojoule. Yes, it's 20 kilojoule, right? Delta E forward minus 40. This is 0. This is minus 40. Delta E forward is equal to product minus reactant, minus 40 minus 0. This is true. This reaction is exothermic. It's true. Why? Because the position of product is lower than the reactant. EA prime is 20, EA prime is not 20, because EA prime is equal to minus 40, or we can say 20 AC minus 40, it will be 60. So the 60 kilojoule per mole, D is the wrong among all of them. Another form of the graph, but EA and EA prime is given. EA is equal to 125, so B is the correct answer, the only one that has 125, and EA is equal to 86. The step-by-step sequence of reaction by which overall chemical chain occurs what is the reaction mechanism. For the reaction, delta E forward is equal to minus 150, EA prime is equal to 250, and EA equals, so guys, delta E forward equals the EA minus EA prime, EA minus EA prime. EA is the requirement, EA is equal to delta E forward plus, take to other side, EA prime. So delta E forward is minus 150 plus 250, okay guys, it will be 100, so 100 kilojoule is the correct answer. In the reaction, delta E reverse minus 30, EA 40, what's the value of EA prime? Guys, delta E reverse is equal to EA prime minus EA. So EA prime is the requirement, take this to the other side. EA prime is equal to delta E reverse plus EA. Delta E reverse is what? Is minus 30 plus 40. So result is a what? A 10 kilojoule, which is A is the correct answer. Maximum or minimum amount of energy that needed to raise reactant to the activated complex is the what? Is the activation energy. B is the correct answer. If a collision between two molecules is very gentle, that means it's lacking of energy. At favorable, the molecules at favorable orientation, it's not talking about orientation, at favorable orientation, reactants, they rebound without reaction, because there will not be an effective collision. To be effective collision needs sufficient energy and favorable orientation. The energy required to transfer the reactant into activated complex, again this appears in ministerial exam question twice, activation energy. The activated complex is not an intermediate. The decomposition of nitrogen dioxide occurs in two steps. This one is the main, and that's the given step, the first step. Which of the following is the possible mechanism of the second step? Let's just flip this, add with the above, you'll get the step. The minimum amount of energy, this is the activation energy, guys. The reactants are leveled at 0. Delta E is 30, EA prime is 20. What's the EA? Delta E forward is equal to EA minus EA prime, guys. So the EA equals the delta E forward plus EA prime. Delta E forward is 30 plus 20, which the EA prime results are 50 kilojoule per mole. The reactants at energy level is 0, delta E is equal to minus 30, EA 20, what's the EA prime? The same calculations. To be effective, a collision requires, this appears several times in a ministerial exam question. How does an energy of activated complex compare with the energy of reactants and product? It's higher than both reactants and product. It's higher than energy of it's higher than both the energy of reactant and energy of product. D is the correct answer. If a collision between molecules is very gentle, the molecules are likely to rebound without reacting. D, this is the second time appears in ministerial exam question. That's the end of the session. Thank you for the attention, guys.